So this is the problem we went over in the class today, right? Right now, I'm at Stony Brook University. Let's invite a graduate student. So you are a graduate student here at Stony Brook University?
Yeah, let's get to the point.
Let me challenge you with a problem.
At the 20-mile mark, he saw a speed limit sign that said 25 mph. Did little Isaac break the law?
Can you draw a diagram?
All right. So D initial, D initial, V initial, A initial. Then here's the sign. And here, I know what the time is.
I think you do know
How would you know?
by algebra using the position
Yeah,
function.
we'll do that part later.
Okay.
But we immediately know the distance. It's given, 20-mile mark. The velocity we will find later, and the acceleration
You want to give up the problem? Okay, sure.
we're gonna find later as well. And finally,
Okay. All right. Sure. Try. Give it a try.
we have T final. Oh, this looks kind of weird. Which is 1.5 hours. So I'll write that as 1.5. Then we have D final, which
At Stony Brook, you don't use unit?
okay. There's not really much space to write units, but if we must, 20 miles, 1.5 hours, and obviously we label everything here with 0 except acceleration. There has to be some acceleration first in order for the car to get moving, or
You sure?
the bike to get moving, I guess. So the thing is, because this is a quadratic function, that means that the acceleration is constant and the velocity is linearly changing. So if the acceleration is constant, how the heck do we find it? Now,
You don't find it. You just give up.
what?
Okay, sure.
What's giving up? Now,
Well, what happened over there? You forgot?
Sorry, buddy.
All right. So what is the D final?
A D final. Well, it's pretty easy to calculate that, even though we don't know it beforehand, because we know T here is 1.5 or 3/2. So we just multiply that in, and we get 40/3 times 9/4, which is equal to 10, 30 miles.
Okay.
So this is not to scale.
So you made a mistake, right?
How?
20 is closer to 30 than to.
I know, but it's not to scale.
Okay.
I drew it there because I didn't know where we were.
Okay, good, good. I can forgive you for that mistake. T1.
All right. How do we know T1?
So at Stony Brook, you don't draw things at scale?
No. Okay. Except if we're in a geometry class.
Okay.
So we have P of T equals 40/3 T squared. Now we just flip that over because we know P of T is valued at 20. So now we just have to find T here. So we get T squared is equal to 20 times 3/40 equals 3/2. So T is obviously just the square root of 3/2, or the square root of 1.5.
It's 1.22. I can tell you that.
Okay, so 1.22. So then,
Position versus time first?
position over.
No, it has to be dt because that's we.
You literally define it as P. Sure. Oh, I forgot. I used the wrong axis. So
No, use the d.
you use P, but okay.
Okay. Now
So-
velocity versus time graph.
All right. So I will put T in V there.
Now acceleration versus time graph. By the way, anytime you can give up.
Okay.
Okay.
So D is obviously going to
How
be
do you know it's parabola?
because of the degree of the function.
Where is the other side of the parabola?
Well, because time can't be negative, we don't care about those.
Why not? We don't want dead people wake up from the graves.
Yeah.
Okay, sure.
Okay. So
2
velocity.
points. I need 2 points. 1 point, the first one and the last one.
All right. Then, you can get your 2 points. 0, 0, and obviously 1.530.
Okay.
So then we have our VT graph, which is going to be linear, and I'll give you that.
I need the 2 point.
Okay, that's very cool. We got 0, 0, and here's the trick. You could use algebra, but that's
You have to use the algebra because at Brooklyn Tech we use algebra. Why are you laughing?
Is this Brooklyn Tech or Stony Brooklyn Tech?
Okay, we use algebra.
Okay, then let's think about how we.
You can give up anytime you want. I see you are low confidence.
What the? How do you know that I'm low?
You're laughing with low confidence. Okay.
Okay. So we have our distance function, 40 over 3t squared. So now how can we find velocity from that? Well, what I'm going to try to do
I can give you a hint. Are you taking a graduate geometry course?
Yeah, that had nothing to do
Use geometry.
Huh?
Area under the VT graph
Okay.
is the distance.
You are correct. Through those means, that should mean that if this is 30,
Before you do
Oh
that,
my
write the
gosh.
equation.
what?
Okay.
What equation?
All right.
We know that the area under the
Sure.
curve is 30
Sure. So
because,
far, so good.
but they don't understand integrals. How would they know?
We don't do integrals at
Then what's your
Brooklyn Tech.
then what's your reasoning for the area under the curve?
We're gonna
being-
talk about it later. But first, do by geometry.
Okay, buddy. So 30 is half BH. B is, so let's erase this. B is going to be 1.5. So we get half times, wait, no. I canceled out the half. So we just get 1.58. So 8 is 40 by those means. No?
Okay, I accept it with some low confidence because I have no confidence on you.
With this technique, this little
Yeah,
trick,
show
you
that
used it-
technique. Yep.
You used it once. Why can't you use it twice?
Sure.
So 40, the area is going to be equal to BH. This is a straight line, so we have a
That's
rectangle.
true.
And 40 over 1.5, what is that? That's 40 times 2
80 over 3.
Yes, that's 80 over 3. Good job,
That's
my
right.
little buddy.
Okay, good.
And since acceleration is constant, this holds true for every single
I want you to do it with three kinematics equation. D is equal to VIT plus half AT square. VF is equal to VI plus AT. And VF square is equal to VI square plus 2AD.
Sure. All right. So D is equal to, well, the distance at the end is 30 miles. VI, that's 0. T, it doesn't really matter because VI is 0 anyway. Was half A, what the heck?
How do you know it's not negative 10 meter per second square?
Huh? Oh, because we're not in free fall?
Good. No, testing you because
So obviously T is 1.5 hours. Boom, you got distracted. So 60 is then half A times, this is 3 over 2 squared, so that's 9 over 4. So then we get 60 times 8 over 9 is equal to the acceleration. So 8 times, whoa, buddy. This supposedly correct
80
equation.
over 3. So where did you mess up? Because I know I have a low confidence on you. So fix it.
Oh shoot. Yeah. Wait. Oh yeah, it's because I forgot to remove this. Sorry, that was a little mess up. But yeah, it should be 60 times 4 over 9. That was kind of funny. So it's 4 over 20, so it is 80.
Now do it V squared.
Oh my gosh. VF squared minus VI squared equals 2AD. So that means that we have VF, which is 40, 1600. VI is 0. And then we have 2. So let's bring that over here. A times D. So 800 over 30, which is 80 over 3.